Hey everybody, this is the lecture about aircraft components, which is our next topic. So, what is an aircraft? An aircraft is a vehicle that can navigate through the atmosphere of a planet by means of a lift force. So, any vehicle that can move through the atmosphere because of lift is an aircraft. So there are three main classifications of aircraft. One is the aerodyne, which includes fixed wing aircrafts like gliders and airplanes. And then the other type of aerodyne is a rotorcraft like a helicopter. The second classification is an aerostat. And an aerostat is like an airship. Some of you guys researched those for history of aviation. They used to be called dirigibles. Nowadays, we basically call them blimps. But those are airships, as well as aerostatic balloons, also known as hot air balloons. The last classification of aircraft is called a ground effect craft, and that is one that just basically hovers over the ground. In this picture, we have a ground effect craft that's hovering over water, but they can hover over land too, and so they just fly really, really close to the surface. So the three main classifications: aerodyne, which include airplanes, gliders, and helicopters; aerostats, which include hot air balloons and blimps; and then ground effect crafts. There are three main controls for flying an aircraft, and we're going to just talk about them in terms of airplanes. One is roll. Roll is the rotation about the longitudinal axis of the plane. The longitudinal axis goes from the nose to the tail, straight through the body of the plane. So the long dimension of the plane from nose to tail is your longitudinal axis. So roll is rotation around that axis. So the wings will start horizontal, and if they roll to the right wing goes down and the left wing goes up. And then if you roll to the left wing goes down and the right wing goes up. So that is roll.
Number 2, we have the traffic on final.
Hi, I'm Dave Pressey with St. Charles Flying Service on behalf of Expert Village.
Roll is when we bank or turn the aircraft's wings. Turning the control yoke right or left will cause the aircraft to bank in the same direction. This is accomplished with the ailerons, hinged surfaces out on the far end of each wing. They are similar in function to the elevator, however they work opposite each other. One goes up while the other goes down. The downward deflected aileron lifts the wing while the upward deflected aileron drops the opposite wing. This simultaneous lifting and dropping causes the aircraft to roll in the direction we desire, thus turning the airplane. But this rolling causes another turning force, yaw, which we'll discuss in its own segment.
The second aircraft control is pitch. Pitch is rotation of an aircraft about the horizontal axis. So a horizontal axis would go from wingtip to wingtip through the plane. So basically pitch is movement of the nose in the up and down directions. So if you pitch up, the nose of the plane goes up, and if you pitch down, the nose of the plane goes down.
Runway 27, number 2, we have the traffic on final.
Hi, I'm Dave Pressey with St. Charles Flying Service on behalf of Expert Village.
We're going to talk about the way in which we move an airplane in flight. Unlike your earthbound vehicle, an airplane can move in all three dimensions. This is accomplished by moving the control surfaces to change the airplane's attitude. There are three axes about which an aircraft moves: pitch, roll, and yaw. Pitch is the up and down movement of the nose. We can adjust the pitch of an aircraft by moving the control yoke forward and backward. Pulling back and forth in such a way moves the elevator, the horizontal hinge surface on the tail. Move the control yoke forward to lower the nose. Move it backward to raise it. An upward movement of the elevator causes the tail to be deflected downward, thus lifting the nose. A downward movement of the elevator raises the tail, thus lowering the nose. Pilots refer to this up or down movement of the nose as changing the aircraft's pitch attitude.
The final aircraft control is yaw. Yaw is rotation about the vertical axis. So if you could put a line from the top of the plane through the plane vertically to the bottom of the plane, that would be a vertical axis. So yaw is movement of the nose in the left and right directions.
Number 2, we have the traffic on final.
Hi, I'm Dave Pressey with St. Charles Flying Service on behalf of Expert Village.
If pitch is the up and down movement of the nose, yaw is the left and right movement of the nose. This is done with the rudder, the vertical hinge surface on the tail. When we step on the rudder pedals in the cockpit, it moves the rudder from side to side. Moving the rudder to the right deflects the tail to the left, thus causing the nose to swing to the right. A left deflected rudder does the opposite, and the nose goes left. This doesn't turn the airplane, it just moves the nose from side to side. This is helpful when turning the aircraft, however, to counteract what is called adverse yaw, or the tendency for the nose initially to swing out opposite the direction of the turn. Adverse yaw is an unavoidable side effect of using the ailerons. The downward deflected aileron on the wing outside of the turn drags that wing rearward. The pilot must use the rudder to compensate for this undesirable yaw.
So let's get into the actual parts of the aircraft. We saw some of them in the videos. They talked about ailerons and elevators and the rudder. So let's talk about all of the parts of the aircraft that contribute to it flying and being useful. So there are 5 main areas of the aircraft. One is the fuselage. Then we have the empennage, which is the entire tail all together, the wings, the power plant, and the landing gear. So let's talk about the functionality of some of these parts. The fuselage provides the crew, the passengers, and the cargo protection from external conditions. And the shape of the fuselage is generally a trade-off between aerodynamics and volume depending on the plane's purpose. You'll see up at the top right, there's a little photo of different style fuselage depending on the planes. So number 1 is a subsonic plane. It goes slower than the speed of sound, and you can kind of see the shape of its fuselage. It's not very big, so it probably only holds a couple of people. And then we have a supersonic jet, which goes faster than the speed of sound. And you can see that the nose is pointier and the fuselage is more narrow. Because it's got to be able to be more aerodynamic to cut through the air at such high speeds. Number 3 is a civilian transport. So basically your commercial airliner, well, number 5 is a cargo plane. So maybe like the FedEx plane or the UPS plane. I mean, you can see that those fuselages are very tall. And they're not as aerodynamic because they do not have to go as fast. They're tall because they're holding cargo and people, right? And so the nice thing about some of the civilian airplanes, the commercial airplanes, is that you can actually, you stand up in the middle, and sometimes, depending on the plane, you can actually stand up while you're in the row of seats underneath the baggage compartment there, the overhead compartment. Fighter jets and hypersonic jets, those are, again, pointy-nosed, small fuselages because they only have to carry 1 or 2 people. Moving to the empennage stabilizes the flight dynamics of pitch and yaw. If you remember back to the little videos, pitch is controlled by the plane's elevators. And those are located on the horizontal part of the empennage. We'll talk about that more in a minute. And then yaw is controlled by the rudder, which is on the vertical part of the empennage. Here you could see different shapes of empennage. And again, it really depends on what that aircraft is for. You could see the one in the middle at the top is an H tail because it looks like an H. The one to its right is a V tail because, well, it looks like a V. We have the T tail down at the bottom. A lot of the commercial planes have high empennages like that. And so you can see they're just different shapes of empennage depending on what kind of plane you have. The power plant is the part of the plane that turns the rotational motion of the engine into thrust. So in a propeller-propelled plane, there's an engine that burns gas, and it has a shaft that runs through the center, and it rotates because of that combustion, and then that rotates the propeller, and that creates the thrust. Okay, so that's how the power plant works. And I think we talk more about the power plant in a few minutes. Turbo propellers replaced piston engines in propeller-powered planes. So nowadays, you're more likely to fly in something called a turboprop. And that just has a different type of engine than what used to exist. And then here is a picture of the turboprop engine. It has different sections. So the first section, the air gets sucked in and is compressed by this compressor section, and then that's pushed back to the combustion chamber where it mixes with the fuel and is ignited, and it burns the fuel to generate lots of heat and energy, and that energy turns a turbine. Okay, so this is a turbine. As it goes through, the exhaust gets expelled out of the back of the engine, but as it goes through, it turns this turbine, which is connected to this long shaft that goes back up to the front. And then that turns, which makes the propeller turn. And then that's how thrust is created. So let's delve into the empennage in more detail. The vertical part of the empennage is called the vertical stabilizer. It provides directional stability, which is stability in the left and right direction, which is yaw. The vertical stabilizer is made up of a fixed fin, so part that does not move, and a movable part called a rudder. The rudder is controlled by pedals up in the pilot's area. So if the pilot steps on the left pedal, the rudder will turn to the left. That causes the tail of the plane to move to the right and the nose of the plane to move to the left. If the pilot steps on the right pedal, the rudder will turn to the right, causing the tail to go to the left and the nose to go to the right, because the plane is one solid piece, right? So if the tail the back end of the plane goes to the left, the front of the plane has to go to the right because it's one solid piece. So that's how yaw is controlled with the rudder. The horizontal stabilizer is the flat part of the empennage. It provides pitch stability, so the up and down motion of the plane's nose. It is made up of fixed fins and a movable elevator. So the elevators are the movable parts of the horizontal stabilizer. There's one on each side. They control pitch. If the pilot pulls the control stick back toward them, so they're pulling it basically out of the dashboard, and I use that term loosely, towards their belly, towards their chest, the elevators will go up. That creates more drag above the horizontal stabilizer of the plane. So it pushes the back of the plane down, right? Because now there's more pressure above the stabilizer. So it pushes the back of the plane down. And because that plane is a fixed, sturdy piece, if the tail goes down, the nose has to go up. So you get more pitch and a higher angle of attack. That creates more lift and more drag. So it really depends on what it is that you're doing. Like, are you taking off or landing or just flying between two places? The last little pieces back here are called trim tabs. Those are controlled by the pilot to reduce the pressure on the flight stick so that it'll be a little easier to use the flight stick or yoke. And it'll be easier to control the plane. And the adjustments to the trim tabs will occur the entire flight, so as to control the lift force as the fuel gets used up. All right, let's break down the power plant. So we zoom in here on the power plant, and it has its own separate parts. The first part is the engine, and we talked about that. These are internal combustion engines, much like that in your car, so they burn gasoline. They provide power to the propeller. They provide the electrical power to the rest of the plane. They provide the vacuum for the instruments, and heat for the pilot and passengers. The cowling is the casing that goes around the engine. It helps to streamline airflow through the engine so that it's not super turbulent and moving all around. It sends it in one nice direction. And it also helps cool the engine, which is very good because right on the other side of this piece is the pilot's legs, right? And if the engine got too hot, then the pilot would get too hot. The propeller is the part of the plane that translates the rotational motion of the engine, right? It goes around and around in a circle, into thrust. So a lot of people think that the propeller spins on its own, kind of like a fan in your bedroom, or I have a fan in my window, and if I turn it off and the wind blows through the open window, it actually spins the propeller, which is what happens for a wind turbine used for alternative energy. But a propeller actually works differently, and it is spun by the engine, and then that motion turns into thrust. And the last important piece of the power plant is the firewall. The firewall is here, and it's between the engine and the cockpit to protect the flight crew from engine fires or extra heat in the engine. Okay, let's zoom in now on the wings. This was the best photo I could get, the best image I could get for the wings to show the separate parts. So it does have a little bit of the back end labeled, the empennage, And then it has the fuselage, the propeller, and landing gear also labeled. But we're going to focus on the wings. So obviously the wings are the longest pieces from one side of the plane to the other. Wings are also called airfoils. So that's an important term, airfoil. That's another word for wings. Wings can come in different shapes and orientations. An elliptical wing is more like oval in shape. Those are the most efficient wings, but they're hardest to make. If you go to the opposite end of the spectrum, you get the trapezoidal wings. The rectangular wings, here in the middle. The rectangle wings are really easy to make. I mean, it's a rectangle, but they have a much lower efficiency. So a happy medium is the trapezoidal wing. So it has a medium efficiency and a medium, as far as level of difficulty to manufacture. For airspeeds close to the speed of sound, those planes have swept wings. So those wings are like swept back to increase lift and decrease drag as they fly faster. The delta wing is for supersonic aircraft, and the Ogivall wing shape is an evolution of the delta form of the wing. So they same purpose. It would be for supersonic aircraft, but you can see that it's a little more curved instead of having these straight edges and corners. Also, the way that the wings are connected to the fuselage can be different. So you can have low wings where they're connected to the bottom of the fuselage, like commercial airliners. You can have mid wings where they're connected to either side of the fuselage, like on a jet, or you can have a high wing where they're connected to the very top of the fuselage, like the little prop plane shown. Ailerons, you can see here, are the green parts of the wings. They are movable and they are the farthest from the fuselage, and ailerons are very important for controlling the roll of the plane. They move opposite each other, as you saw in the video earlier. So if one aileron goes up, the other one automatically goes down. The aileron that goes up, right, it will fold up and the back edge will become perpendicular to the wing, or at least close to perpendicular. And that increases drag on that side of the plane, which increases the pressure above the wing. If you have more pressure above the wing, it is going to push that wing down. That will cause the other wing to go up. So if the pilot turns their control stick to the left wing aileron will go up, causing more pressure, pushing the left wing down. And because the plane is a solid piece, if the left side goes down, the right side has to go up. And so your plane rolls to the left. If the pilot turns their stick to the right, it's equivalent to turning your steering wheel in your car to the right, then you put the right aileron up, and that increases the pressure above the right wing, pushing the right wing down and making the left wing come up with less pressure on top of it. So if your right wing drops, now your plane is going to roll to the right. Okay, it is really important that you know how to walk through what happens to the control stick and then how that corresponds to the ailerons, elevators, or rudder. The flaps are closest to the fuselage. Okay, flaps, fuselage. Okay, they start with the same letter. The flaps are used during takeoff and landing to increase the curvature of the wing. So they're used at lower speeds to produce a high angle of attack and be able to take off and land. So when you take off, obviously you want the nose to get off the ground first. So you can actually see the flaps on the airplane if you sit behind the wings, and they'll come out of the wing and they'll move toward the back, and they increase that curvature going over the wing. And it'll stay that way until the plane gets to climb up to it's close to its elevation where it's going to fly. And then you'll see as the plane levels out, the flaps are taken in, and because you don't need them anymore, right? Because now you're generating lift by your speed and the airfoils and stuff like that, and you're controlling the plane with the ailerons, elevator, and rudder. When you're landing a plane, you want the nose to touch down last. So you have to have a higher angle of attack at landing as well. So the flaps come back out to create higher lift so that the nose of the plane touches down after the other landing gear. And if you've ever flown on a plane or fly on a plane again, you're definitely going to want to sit behind the window so you can watch that. Behind the wings. Breaking down the wing itself. If we took the wing off the airplane and we cut it in half from front to back, this is what it would look like on the inside. Okay. So, this is a nice curved wing. This is called the airfoil. All right. The curvature itself is called camber. C-A-M-B-E-R, camber. Notice that the upper camber is different than the lower camber. The top of the wing is more curved than the bottom of the wing. That helps with airflow around the wing. And this goes back to the video about how airplanes fly from our previous PowerPoint on forces of flight. The wind is coming in, that's these horizontal lines, okay? Those just represent the wind. And the air molecules hit the wing on the leading edge, the edge that comes in the front. So some of the air is pushed above the wing and some of the air is pushed below the wing. It has to meet back up here at the trailing edge at the same exact time. So the air that comes up and has to take the longer path over the top of the wing has to move faster. Okay, so that faster moving air creates less pressure. That's called Bernoulli's principle. And less pressure above the wing and more pressure below the wing equal lift. So your wing is lifted and your plane is lifted up. The angle at which the wing is attached to the plane and will hit the wind is called the angle of attack. So if the wing were mounted onto the plane more so that this chord line was horizontal, you would have a very low angle of attack. But they actually mount the wings on the plane so they already have an angle of attack. That helps push the air around the wing, creating less pressure on top and more pressure on the bottom. So we have the leading edge, which points to the front of the plane. The trailing edge is the edge of the wing that points to the back of the plane. The chord is the distance from the front to the back. The chord is the distance between those two edges. The camber is the amount of curvature of your wing. Okay. Another term we're going to need, I think if I fast forward here, is the span. The span of the wing is the distance from the fuselage to the wing tip. You've probably heard that term before because sometimes people will tell you to stretch out your arms side to side, and basically the distance from the tips of your middle fingers, like the distance in between those, because usually most people's middle fingers are longest, that's basically your wingspan, okay, your arm span. So the span of the wing is from the fuselage to the wing tip. Here we have the chord defined, the distance from the front of the wing to the back of the wing. And then we have the camber, which is the amount of curvature of the surface. So I said all of these things. And then we have the angle of attack, which is the steepness of the wing. And so these are really important nomenclature or vocabulary words, and you're definitely going to see those on your assignment, your practice assignment, and your graded assignment. And that concludes the components of the aircraft. I strongly suggest watching this again and filling out the guided notes that go with it. You're going to get a practice page that will allow you to use the video and the notes to label the parts of an aircraft and to describe what those parts are for. And then your next graded assignment that will be due on the 24th is the components of an aircraft quiz. So your next graded assignment is the components of an aircraft quiz, and that will be due on May 24.